Now, to be able to explain the other two ways that heat can travel, apart from radiation, we just need to understand a little bit about how particles are arranged in different materials. So first of all, if I have a lump of solid, so the wood of the table, the glass that I drink from, the particles in a solid are really, really tightly packed together. They'll be in some fairly ordered arrangement. They'll be close to each other, they'll be touching, but they won't be able to move. Well, I say they won't be able to move. They won't be able to move position, but they will be able to vibrate. They will be able to move around the position that they're in, and that becomes really useful later. Now, if I gave those particles more and more energy, they would move more and more. And eventually there would come a point where they would move so much that they would no longer be held in that really rigid arrangement, but they would actually start to move around, to move past each other, to flow over the top of each other. Now, they would still be close enough to be touching. They would still have the same volume all of the time, but their shape would be able to change. Now, that's what we'd call a liquid. And liquids are one of the types of material that we could call a fluid. The other type of fluid is a gas, and if I heat a liquid even more, the particles gain more and more energy, and eventually they overcome the attraction that's holding them together in this liquid arrangement, and they can fly off independently and zoom around whatever the container they're in. And so in a gas, you would have lots of these particles zipping around really, really fast. And because they're zipping around, they're not touching each other, they're not close to each other. But they can flow in the same way that liquids can. They can move over the top of each other. And that's why we can call these two groups of things together fluids. So here we have solids and liquids and gases, which together we're going to call fluids. So how on earth can heat travel through a solid? Well, the answer is a process called conduction. And conduction will only happen in solids. It's absolutely imperative that you know that this is only in solids. And it's all to do with particles vibrating. Now, I just want to emphasize that it's all to do with particles, because that instantly means that this cannot happen in a vacuum, because there are no particles to vibrate. I want to emphasize again, this is only in solids, which means that as soon as I have a liquid or a gas, conduction cannot happen, because it'll only happen in solids. So how does it work? Well, let's imagine I have a rod of a solid. This might be a metal bar. And if I heat one end of the solid, so I put it over a flame, let's say, so I'm heating this end of the solid, then gradually this solid particle here is going to get really, really hot. And when solid particles get hot, they move even more. So this particle is moving backwards and forwards. It can't leave its position, because that would mean it would starting to become a liquid, but it can vibrate around its position as it is. And it will eventually bump into this particular particle here, and it will gain some of that energy, and gradually it'll bump into the next one, and it'll bump into the next one, and it'll bump into the next one. And you can see the heat energy is transferred along the solid rod. Now, good conductors are metals, and partly that's because they have some free electrons that are free to move to carry some of this heat energy along. But all solids will perform conduction to some degree, even though none of them are anywhere near as good as metals. So what about in fluids? Well, in fluids, it's a little bit different. It's all to do with a process called convection. Now, to understand this, I just need to take two samples of a fluid. So at the top, I'm just going to take, this is quite a cold gas. You can tell it's a gas because the particles are quite far apart and they're all moving around. And this is quite cold. They're zipping around, but nowhere near as much. As if I heated them up even more, then you would see these particles with so much more energy, moving so much faster, they'd take up so much more space. So this is a cold gas, and this is a hot gas. Now, if I take a sample of this gas, I just want, let's say, 1 meter cubed of gas. So I take a cube and I gather 1 meter cube of gas, and you can see the 3 particles in that cube. And I then take the same size cube of the hot gas. Oh, there's only 1 particle in there. So that means the same volume of a cold gas and a hot gas would weigh different amounts. This would be much heavier. This is much lighter for the same volume. we can say that the cold gas is more dense, whereas the hot gas is less dense. Now, how does that have any effect on heat travelling in a liquid or a gas? Well, let's imagine that I'm sitting in my living room. And as you can see, I'm also a high quality artist. And at the other side of my living room, I have a fire. Now, how on earth can I feel the heat from that fire? Well, straight away, I hope you realise that I can get some of it by infrared radiation, because it will fly straight at me from the fire. Very good. Some of you might say, well, won't there be some conduction because the floor will get warm and that's a solid, and so that means that the particles will vibrate and the energy will get passed on all the way through the floor. And you're absolutely right, that would happen. But what would happen even more is the process of convection. If I look at these air particles here, now air is a gas and gas is a fluid. As they get heated up, they will gradually expand. Now the particles don't expand, but they move faster, so they take up more space. So the gas expands. So that hot gas, because it's expanding, it's becoming less dense. And things that are less dense float on top of things that are more dense. And so it rises. Brilliant. Now, that would be really worrying if suddenly I was left with no gas. But of course, other gas gets sucked in to take its place. And it will eventually get hot, get heated, and rise. Now over here on this side of the room, I have some cooler gas. And cool gas, well, it's more dense because it's got all of its molecules crammed together in a smaller space. And so that cool gas will fall. And it'll be replaced by the hot gas that is rising. And gradually this will set up what we call a convection current, a circular current that will carry heat energy from the fire all the way around the room. And that's the third way that heat can travel. We've got convection in fluids, liquids and gases, conduction through solids, and infrared radiation.